Okay, let's get started. Welcome, everyone. I think I'm the only one standing between you and lunch, so we'll try to make this as interactive as possible. If you feel free to ask questions during. I just think that it makes this kind of session more interesting when we do that. My name is Igal Edry. I'm a lead program manager in Windows Server, and this talk is going to be about Windows Server as the infrastructure for building clouds, hosted clouds. I've been involved in the area of how to build clouds with Windows Server for the last 3 years. In Windows Server 2012, I've been the scenario owner for Windows Server for bringing together all of those features that we need to make Windows Server a better platform for cloud infrastructure. In Windows Server 2012 R2, I've been owning Windows Server deployment scenarios. I thought it would be a great thing to revisit a lot of the things we did in Server 2012 and then go and look at what we've changed or what was enhanced in Server 2012 R2. So this session will really be about a mix of 2012, then the evolution into 2012 R2, and I'll try to give you the picture of what we did there. We'll talk about Windows Server 2012 as the cloud infrastructure and about the improvements in R2. And this is a Windows Server session, so we'll spend most of the time on really the infrastructure. What does Windows Server bring to the table in terms of enabling you to build a highly efficient, cost-effective cloud? So we'll look at how you design a cloud infrastructure for a specific scenario for infrastructure as a service using Windows Server, and how does the relevant features in Windows Server help you. I have Hector here with me from the VMM team to actually help with a deployment demo. And we'll talk about, after we've covered the infrastructure, we'll talk a little bit about how you scale this and how you add management, network connectivity, so that we break out of the infrastructure piece of the Windows Server piece in building a cloud to the holistic view of what it actually means to build a cloud and what other technologies we have at Microsoft that will help you build a cloud when you go back to your own businesses. So I'm hoping to give you both the broad overview of what do we have as relevant technologies for cloud, but go deep into what Windows Server has to offer in that space. How many of you have actually had a chance to deploy Server 2012 already? Can you raise your hand? Most people, great. So I guess we'll spend more time on what's the new things. In some cases, I see we see people that have not yet had a chance with the Server 2012, but I think we'll be able to go deeper here. So let's get started. When Windows Server 2012 was designed or was envisioned, a key pillar of Windows Server was to be a cloud-optimized operating system, which means to be able to build clouds using Windows Server. We all know that Azure runs on Windows Server, basically, and we wanted to make sure that any customer, enterprises, hostels, can actually use the platform to build a high-scale cloud. So we've invested our efforts in Windows Server around this thing called hosted cloud scenario. And as part of the scenario, we basically looked at 3 different pillars. We looked at what it takes to make Windows Server a very dynamic multi-tenant environment, enable building clouds that are dynamic and multi-tenant. We looked at what does it take to make Windows Server highly scalable and lower the cost of building a cloud infrastructure using it. And we looked at, because this is a cloud and it has to be large scale, we looked at manageability, how do we automate things, how do we make it extensible so that you can add capabilities on top of what's in the platform. And we basically arranged our investment in Server around these 3 buckets. And when Server 2012 came out, you saw a large number of features, all designed to enable that scenario, all designed to make Windows Server a great cloud-optimized operating system. So on the dynamic and multi-tenant, we've introduced network virtualization. We've introduced policies to enable you to isolate between tenants, isolate between different traffic flows, enable quality of service policies so that you can guarantee relevant network bandwidth for different traffic flows and tenants. We've invested in features around performance metrics, being able to measure what's going on, because if you're building a cloud, you want to know what's going on, and you want to base your charging based on that. We've introduced live and storage migration, so everything is very dynamic. Any VM can move around in the infrastructure. We've taken all of the boundaries away from live migration. You can live migrate from host to host. You can live migrate across clusters. We can live migrate or storage migrate. So you move the storage around. Basically, decouple the logical layer of what you run on the cloud, all of the VMs and all of the storage, from the physical layer that is actually providing the compute and storage capacity, right? We've introduced ability for cross-premise connectivity, which becomes the infrastructure for enabling hybrid cloud scenarios, where you can connect your resources in the cloud to resources that are on-premise. All of that made for the first pillar, which is let's make sure the platform is very dynamic and multi-tenant. Then we've looked at scale. And if you want to build a cloud, it has to be something that scales well. And at scale, we looked at compute, network, and storage as areas of investments, and came up again with a series of a set of features that will enable Windows Server to scale well in a cloud environment. So Server 2012 has support for much larger hosts than before. It can run much larger VMs. You can run more VMs on a host. You can run large clusters. All of these will enable you to build a more scalable compute infrastructure, right? On the network side, we took an approach that was very focused on the hardware offloads. So basically, the way to scale is to take away as much of the network processing as possible from the main processor, free the processor to run VMs, because that's what it's supposed to do, and offload a lot of network processing tasks to the NICs. And we've worked with the ecosystem to highlight or to light up a lot of NIC features that will do offload for various features. So SRLV is one, RDMA is one. These basically enable us to run a network at higher performance and get to higher scale. On the storage front, we've invested a lot in lowering the cost of storage. And I'm sure you all have seen already the Hyper-V over SMB features, the ability to use low-cost storage, basic file servers, JBods connected to them as your main storage for virtualization is something new that was introduced in 2012. So we've introduced storage spaces as well, thin provisioning. Those features basically ended up contributing to the story of low-cost storage at high scale that makes, again, Windows Server a better platform for building a cloud on. Last, on the manageability and extensibility front, the big leap there was around PowerShell. So in Server 2008-02, we had about 150 PowerShell commandlets, I think. In 2012, we jumped to over 2,400 commandlets. Everything is PowerShell manageable, so you can automate all of the tasks across the data center. And again, this makes Windows Server a much better operating system to be operated at scale and build a cloud from. So those are all investment in 2012. And when we released 2012, we really believe that we've made a significant breakthrough in making Windows Server a great platform for the cloud. And internally, we've actually already started deploying Server 2012 as the new operating system in Azure. So we are rolling out Server 2012 there. We are using all of these capabilities. Really great platform for building a cloud on. 2012-02, we basically continued to improve on those capabilities and on the same pillars, adding more capabilities that will make Server 2012-02 an even better cloud-optimized operating system. If you look at compute, we've now taken RDMA, which we used for a fast storage access in 2012, and we've leveraged that also for live migration, so you can make faster live migration over RDMA networks. We've enabled also live migration from previous versions, so you can live migrate from 2012 to 2012-02 and enable a smoother migration transition scenario. We've added features like VHDX, shared VHDX, which will enable you to do a guest clustering on a 2012.2 system where you have file servers as your basic storage and not iSCSI devices or fiber channel SANs. You need the VHDX for guest clustering. On the storage front, we've continued to improve the performance. We've improved by adding support for tiering. We've improved by adding write-back cache. We are smarter at how we redirect traffic from Hyper-V hosts who are using a cluster file server to the relevant node within the file server that owns that piece of storage. We've introduced DDoS for VDI workloads, improved our iSCSI target for VHDX support. Again, storage enhancements that are making the platform better. It builds on the foundation that we've done in 2012.2, but it adds more capabilities that makes it even more optimized. Same on the network side. We've basically taken the network virtualization that we started in 2012 and added support for a multi-tenant gateway for network virtualization, and added some new enhancements and new features in the network. And on the management side, we've continued to improve the manageability of Windows Server, and two notable features that we'll talk about are desired state config and the data center abstraction layer. What I will try to do in this session is put all of these features in the right context, because if you look at them as individual features, it is very easy to get confused between which one is relevant where and how do I actually use them for building a cloud. What we'll do during most of this session is take those features and like put them in the right context of I want to build a cloud, where are they relevant, how do I actually use them. And I also give you pointers to relevant sessions on some of those features when it makes sense, because this is really too broad to cover in one session. What we can do is go deep on some area, like understand the structure of this cloud, but get some follow-ups on the rest, because it doesn't fit into a single session. One thing that is, I believe, the most significant in this release is actually not these features, but it's this alignment that we've done between Windows Server and System Center. If in Server 2012, we've built the foundation to help you build the cloud, but it still was at the operating system level, at the foundation level, in Server 2012.2, we've aligned Server with System Center, which gives you a complete solution enables you to build a cloud that uses all of these new capabilities with the management built in from day zero. So the alignment with System Center 2012.2 is really a critical piece of this wave of releases that we are coming with, right? It's both platform improvement, but it's also a whole set of management support that uses these features and enables you to use them in a practical way and actually start building your clouds with Windows Server. So by now, I'm hoping you're here because you believe that we've actually did the right set of investments. But let's talk about how we actually use those features. How do I actually build the cloud with these set of capabilities that are built into the platform? How do I architect the relevant pieces of my cloud infrastructure? How do I use the relevant technologies that Microsoft has? How do I build the cloud? So in order to do that, I would like to focus on a very specific scenario. I would like to focus on a scenario of hosters building an infrastructure as a service cloud to be consumed in a self-service way, basically a requestable cloud that is providing availability, providing ability to charge, is scalable, and is built at an attractive cost. And obviously, we want to do that with Windows Server 2012 and with System Center 2012.2, right? How many of you here are actually hosters? Okay, significant number. Enterprises who are building an internal private cloud? Okay, so when I say hoster, I really mean both of you. Because the way I think about hosters, and I've been meeting many of them, both from the true service provider as well as enterprises building those private cloud, you see a lot of symmetry between the requirements of those two groups, right? At the end of the day, you want to build a pool of capacity that people can connect to and ask for resources. And it may be a public cloud where you can go in and, as an external consumer of the service provider, consume those resources, Or it may be a private cloud where you come in as a departmental customer or a group within the org and consume the same resources the same way. There are some differences in the way you want to do charging, but really the key capabilities are the same. So think about those two groups of hosters and enterprises building private clouds as really very similar in the requirements, and we'll talk about how you actually architect your private cloud or your hosted cloud to do that. Okay. So in order to talk about building a cloud, let's start with a blueprint of what a cloud looks like. When you want to build a cloud, what does it actually mean? Okay? So you start by having some management stack. In our case, it obviously was going to be System Center, but you start by setting up some management stack that will allow you to bootstrap this cloud environment and use that to build your cloud with. Once you've built that and you've connected to that management stack, you will connect, if the clicker works, you would start provisioning some basic compute and storage capacity. So you would start provisioning Hyper-V hosts, you would start provisioning storage nodes, and obviously you want to do it at scale, so you would add more scale units of more compute, more storage. Maybe you want more storage than compute, so you can have like a different mix. And you build your system that basically has this kind of like foundational unit, the management with the basic compute and storage unit, with scale units that you decide on the size and decide on how you want to architect them. And let's call that, like, this is kind of like your cloud stamp. This is the unit that you consider to be the cloud. Once you do that, you want to allow your users to come in through some portal and connect to the cloud and start consuming resources. And when they do that, they start placing VMs on your cloud, right? And when they start placing VMs on your cloud, they want these VMs to be able to connect outside. So they go out through some network gateways, firewall, VPNs, etc., and connect back to the internet or back through the internet to their own sites and create hybrid cloud scenarios. This is really the thing you want to build, right? And what we'll do is we'll start working on this, like talking about these different units, and we will focus a lot on the infrastructure because that's where the Windows Server capabilities really light up. But we'll also talk about the other units, and we'll talk about what capabilities we have outside of a Windows Server that enables you to do that. So let's get started with the infrastructure, and let's dive deep into how this basic unit, this basic capacity of compute and storage can look like when built on Windows Server to be most efficient and well-designed. So you have all of these features, and we'll try to help you understand them in the right context and select the right ones to use and build your infrastructure based on it. So I've been working with many hosters in the last 3 years, trying to understand what are the key considerations, the key questions you go through when you start designing this infrastructure. What do I need to think of? And obviously there are a lot of requirements around I need to have high availability, I need to think about performance, I have some reliability goals, you need to weigh in security, scalability, cost. But at the end of the day, you really end up thinking about 4 things. You end up thinking about the workloads that you want to run. You end up thinking about your network topology, about your storage approach, and about your resiliency. It's kind of like easy to think about this problem of designing a cloud through this lens of these 4 questions and come up with an understanding of how do I want to architect my cloud. So we'll do that. So let's start with the workloads. When you are designing a cloud for running, obviously, VMs as your workloads, you really start by thinking about the type of VMs, the type of workloads that you're going to run. And the first question you ask is, am I going to build something that will run cloud-aware applications, modern applications that are going to be designed to run in a cloud environment? Or do I also want to run any type of application that wasn't designed with cloud in mind and be able to run this in this environment and provide it with the right SLAs, the right support for running it. And you can build a cloud with Windows Server to address both, right? And if you build an IaaS cloud, you really do need to think about both, because you're not going to just run new types of applications, especially if you're serving enterprise customers. You will have a lot of line of business applications that you'll need to run that weren't designed to run in a cloud environment. So you want to be able to support both types of apps. So from your perspective, you're really managing physical servers, you're managing provisioning of VMs, and you're letting your tenants manage their apps, in this case of a legacy app. You also want to think about the workload performance. And this is a place where I believe we had a big change in the mindset between pre-cloud or like virtualization deployments to thinking about a cloud. If you are running workload and trying to design your infrastructure in a way that is very tailored to the workload, you're actually going to get things very complicated. You still may want to you want to try to run this on as much uniform infrastructure as possible. You may want to run, like, 2-socket servers are really the place where you get the best ROI. You may need some places where you want to run large workloads, and some may benefit from some hardware acceleration. But you want to design this really to run all workloads well. And the other thing you want to think about is the trust model that you have. And again, in the IaaS case, usually you don't trust the apps, right? Your customers are some external customers, and one of the favorite quotes I had from some hoster I met a while back, which maybe is actually here in the room, I don't know, was about how in the pre-cloud era, you had to worry about security between the inside and the outside, and in the cloud era, you have to worry about the evil within, about your tenants actually trying to attack you from within your own cloud environment, and you don't trust anyone, basically. That's the key thing. So if we apply this workload consideration to the design point of how do I architect my cloud for supporting workloads, you really want to keep it simple. And that's how you get to the model of standardized VMs, like T-shirts VM. I will have a small one, extra large one. I would have them self-serviced. I would have an SLA around them. But I'm not designing the cloud infrastructure for specific workload. I'm actually designing the cloud infrastructure for running all workloads well. That's what I do. And again, you may have some variants and some areas of your data center, of your cloud environment that are more optimized for some workloads than others, but you really don't want to have an infrastructure that is very heterogeneous, very, like, a lot of different architectures all over the place to support different workloads, a rack to run Exchange well, and a rack to run SharePoint well, and a rack to run Link well, and a rack to run whatever. You want some kind of homogeneity built into your infrastructure. So really a change of mindset from thinking about designing the virtualization infrastructure for a specific workload to a mindset where you're designing it for T-shirt size, simplified view VMs that can run everything well and obviously provide good performance, right? So this is really what you want to do from a workload perspective. Basically almost stop thinking about the workload so much and design something that works well for everyone. From a networking point of view, if you look at what's going on within this cloud environment, you are within your infrastructure, you are going to have basically two types of data streams, two types of network flows. You're going to have the network flow that you as the hoster own, everything that is generated by the hosts, the cluster traffic, the live migration, the storage access, the management traffic, all of that is your traffic, right? You're basically responsible for that. You're the one generating it. And then you are going to have the VMs traffic. All of your tenants are going to come in with VMs and run their own traffic on your infrastructure. And it's kind of like you have a trust boundary between the two. You can trust your own traffic. You know what's going on there. And you can't really trust your tenants. And you can't trust the tenants both for cases where they try to breach to get to your side of the fence, your traffic, but also you want to isolate tenants from other tenants. So you want to provide the right guarantees for tenants to know that you've addressed like the noisy neighbor problem, where one tenant may starve resources away from another tenant, things like that. So from a traffic isolation consideration, Windows Server has a lot of built-in features to help you do ACLs between those different traffic flows, quality of service, VM quality of service between VMs. Hyper-V network virtualization allows you to better isolate VMs, tenants from each other. You may also want to use physical isolation to actually separate those two worlds, right? Your data center traffic from your tenant traffic and run them on completely separate networks. This is a key consideration that will influence the way your network is going to look like. Okay, so you want to make that decision. Another area that is related to networking that you want to think about is all of the offloads that we've lit up in Windows Server 2012. Which one of them you're going to adopt? Because that's going to have a direct impact on the hardware you select to run your network infrastructure on, right? So there are a lot of offloads, and I'll try here. The main point of this slide is to help you understand where they fit, because each of them has a special role, and each of them enables a specific use case that you can make better by using the right offload. So in Server 2012, we enabled something called DCB, data center bridging. Think of DCB as offloading quality of service policies for the host traffic. So if you have DCB on the host, and the picture here is really like this. Actually, you're mostly here. The traffic flow that you have within the host around storage, live migration, management, I've drawn them as if they're running through separate NICs, although maybe they're actually going to share NICs, but just for the illustration purpose. And DCB really helps you for doing quality of service offload to the hardware between those traffic flows. If you want to do that, then that's where you'll use DCB for. RDMA is a case where it's really relevant only for the storage traffic. The only place where Server 2012 uses RDMA is for doing SMB traffic. And actually, in Server 2012 R2, it's also relevant on this path here for live migration. So if you want to do very high-performant storage access to the file servers as well as live migration, RDMA can come in handy. RC and RSS are both features for enable high scaling of the network traffic, relevant mostly for host traffic access. Were you trying to ask a question? No? Okay. VMQ for running large VMs and enabling VMs to process a lot of traffic. And again, and that's relevant on the NIC that is connected, the Hyper-V switch, to the VMs. You can also do IPsec task offload, same case, which is it actually helps VMs do IPsec in a better way. RSS and SRIOV are relevant. They are basically features that will allow a VM to scale better in terms of processing network traffic. And a point to note about SRIOV is that it bypasses the switch. So when you decide to use SRIOV, you should be aware of the fact that the VM will talk directly to the NIC and will not actually go through the switch. So a lot of the switch features, like network virtualization and like ACLs policies isolation policies between the VMs, would actually not be in effect anymore. One new feature that came up in Server 2012 R2 is VRSS, which is like RSS but in the NIC. So that's a new capabilities. If you want to learn more about these offloads, there is a great white paper that I have the link here for. There is no session about that in R2. Kind of like the way we work is we've done that in 2012. There was a lot of session in 2012 about it. It's all out there. You can go and you can read the paper or even watch the sessions about this that are recorded on Channel 9 and learn more about it. Another point to note about the offloads is that because they are all very designed for specific cases, they sometimes have cases where they don't interact well with each other. So, for example, if you want to use RDMA with NIC teaming, you can't. We'll talk about how you actually can do something similar. but not with NIC teaming. And obviously, you need the right hardware, and the right hardware may mean the NICs, but also might mean BIOS support in the servers. So for SRRV, for example, you actually need the BIOS that is SRRV aware if you want to take advantage of that feature. So these are kind of like offloads that you may want to light up or you may want to use in your infrastructure when you're designing your cloud based on Windows Server. Let's move to storage. We've started with an assumption that we have compute nodes, like the rightmost side diagram, which is like you have the compute and you have the storage separated, but Windows Server actually supports more than that. You can build a Windows Server cloud environment or virtualized environment that will follow that model, but also one that will follow the model where the compute and storage are together. And if you look at even how many of you have been in Mark Rusinovich's talk yesterday about Azure? Actually, in this room, a few. Okay, some. And you probably actually noticed, or maybe you noticed that in the case of Azure, a lot of the storage is actually in the compute nodes, right? If you run a VM, you get access to local storage. So it's very legitimate to do both, and that's obviously based on Windows Server. So let's start by covering what are the options and then see why I actually drew it the way I did with storage separated. So if you want to do a Windows Server-based compute and storage that are scaling together, you may have disks within the Hyper-V servers and basically just access local storage. This is what Azure does for a lot of its storage. A lot of the VMs actually can access local disks, Stripe disks that are running locally in it. You don't get infrastructure high availability anymore if you do that. You basically are kind of like tying your infrastructure design to assuming that the workload can survive failures, right? Because if it's local and the host goes down, the storage goes down with it. In an Azure case, that's perfectly okay because the app resiliency is built at a different level. But you can do that. In Windows Server 2012, we introduced the feature of spaces over shared SAS. And you can actually run a Hyper-V cluster that will connect to a shared SAS storage. And we'll actually get HA together with the localability of the storage, right? So you can actually do infrastructure HA with Windows Server 2012. So those two options are available to you. You obviously can do the thing that we all did until 2012, and I'm guessing most people still do, which is to use SAN as your storage, either iSCSI or Fiber Channel. And again, in 2012, we've introduced the support for file servers as your storage. So you can run file servers, and file servers can be connected to shared SAS disks. You can even put the file servers in front of iSCSI or Fiber Channel storage. When we started talking about that in 2012, people asked, why would I do that? And I asked back, okay, so why would you, right? Because it is possible. It's not necessarily the right thing to do, but there are many considerations. The main consideration that we've seen since then is really as a transition period. So you put your file servers in front of existing storage because you have that storage already. You want to move to a file server-based approach. Over time, you will move to lower-cost storage with the JBODs and SAS connections. But you basically get some uniformity. And again, uniformity is very important in building a cloud because it scales much better. It is much easier to manage a uniform environment than to manage an environment where you have lots of different designs flying around the data center. So you can do all of these options. And if we go back to the IaaS case, where one key requirement or key attribute of IaaS is that you're building a cloud where you don't really know in advance how much storage you would need, how much compute you would need. It really depends on how your tenants are going to behave, what are they going to require. And you want the flexibility to add more compute or more storage depending on your business need at that point. Then we can rule out this option of togetherness. You can still do it with Windows Server, but for the case that we're talking about here, we believe that this is not the right choice. Then, between the two others, the file server-based with SAS is simply more cost-effective. And we've invested a lot of effort in making that really low-cost, high-performance storage that will serve your needs for IaaS, which is why we are basically investing our time in getting that option to work best. So in terms of storage scaling, for building an IaaS cloud, we really believe that this is the right path to go with. Okay, let's talk about resiliency. And basically the question is, what's your approach? What happens when hardware fails? What do you want your SLA to look like in this case? Do you want to design the infrastructure so that hardware failures are not exposed to your tenants, to your users? Or do you want to design the infrastructure where some of it is actually exposed out? And those two approaches can be represented from an infrastructure perspective as either you're building resiliency into, and this is kind of like two extremes. There is a wide range of options in the middle, but just for the sake of clarity, one extreme is you're going to design an infrastructure that is highly available, two of everything, resilient hardware, double networking, or maybe even more, a Hyper-V failover clustering so that if one machine or one server goes down, the VMs will automatically failover to other members of the cluster. This basically is an approach where you're saying, I want to provide a very high-level SLA, high-value SLA to my customers, and they can run any app on my cloud, and any hardware failure that may happen in my environment is basically not really exposed to the tenants. They get the benefit of resiliency provided by the infrastructure. As opposed to the other approach, which is it's an app problem, right? If you run an IaaS VM on Azure, Amazon, OpenStack clouds, that's really the approach, where you don't really get a lot of resiliency guarantees from the infrastructure for the case of a VM that is running there. If the app was designed to sustain failures, great. If the app wasn't, it needs to be done. It needs to be modified or rewritten or designed to take care of its own failures, run on multiple failure domains, etc. So it's really the question of, am I building that into the infrastructure, which is the left side, or am I going to assume that the applications are going to take care of this for themselves? There is no clear answer here. You can do a much better job with Windows Server. Like Windows Server has all of the capabilities to enable you to do the left thing, but it's really a business decision of where you want to be and what's the profile of your customers, what are you going to run on their clouds. You can do both. I have like a checkbox on the left side to highlight the fact that you can actually do that with Windows Server, and that can be a great differentiator. But again, it's really a business decision. It costs more, so you have to make this decision yourself. So we have this basic 4 consideration in place when we understand the design point around network and workload and storage and resiliency. How do I actually build it? And when Windows Server 2012 came out, we spent a lot of effort taking all of these considerations and mapping them into a few representative configurations that we documented, we talked about. We even released PowerShell scripts that will allow you to deploy them automatically, just like run PowerShell on a few servers and configure them to become one of these 3 configs. And all of this is currently available on the Microsoft site as guidance on how to use Windows Server 2012 as your cloud infrastructure. If we apply the IaaS requirements here, and we want to build something that can run all of the workloads well, which is what we said we need for IaaS, and can scale well, and can scale compute and storage separately, and provide lower cost storage from both capacity point of view as well as IOPS. Provide high bandwidth network, provide isolation between the data center and the tenant network, because remember, we are now a hoster and we don't really trust our tenants. We have to. And can support resiliency if we need to make it happen, then you really want to focus on this middle one as your building block. That's your basic scale unit for compute and storage for a cloud. That's how it needs to look like. You obviously can do some variants here, but this sample, which is, as I said, available on the web, is really the one that lights up the most optimized basic building block for Windows Server as a cloud infrastructure. Let's take one deeper look into which features it actually uses and how they fit into the picture, and then we get to a demo. So on the file server side, that's where you'll connect the JBODs and use SAS, and then use storage spaces with a pool and a space and cluster shared volume, and basically expose that storage as file shares from a file server cluster. And then your Hyper-V server will be able to use a high bandwidth data center network using RDMA for the high bandwidth to actually access the storage. Note that in this case, you can run everything on the file server. So even the VMs that are running, like the live copies of the VM that are being used for the VMs there, can actually reside on these file server storage. The only thing you still need in those Hyper-V servers is the local disk to boot it, but everything else can just be on the file shares, right? So run all of the storage there. There is a great session that talks about how you do that with 2012 R2. In terms of new capabilities that we have enabled in 2012 R2, really tiering is one, so you can have your disks with a mix of spindles and SSDs and get high performance and get different levels of pools of different tiers of storage available. You can have the feature for the auto redirection will make sure that the Hyper-V server that needs to access the storage on a file server will go over the network straight to the right host that owns the pool or the share that is actually being used by that VMs. And we have added storage cross policies as well. All of this is covered in different sessions, but that's the key thing around storage, right? In terms of network, you have, assuming you want resiliency, you can use NIC teaming as the way to provide resiliency and basically team the NICs together. You can start applying cross policies at the OS level to make sure that, let's say, cluster traffic always gets some minimum fair share that it needs to enable the heartbeat, and storage access gets the right level of access, and in the Hyper-V host, that live migration gets some guarantees but does not get too much traffic, too much bandwidth, or it doesn't starve storage access, for example. So all of these features can use NIC teaming and the operating system cross policies, as well as you can use NIC teaming for the tenant network and for the switch cross policies to isolate between VMs. And obviously, network virtualization will also fit here as part of your strategy. New things that we've added there are NIC teaming, especially here, will behave better in Server 2012 R2. Will spread the load better between those two NICs. So it has a new dynamic mode that will actually be more aware of what's going on here between the VMs in a network virtualized environment and spread the load well. And we have added the support for shared VHDX, so you can have a VHDX residing on a share here, being used by multiple VMs to do guest clustering without the need for an iSCSI storage. A note there was that NIC teaming and RDMA do not really work together, so it's not an accident that there is no RDMA here. If you do team, you lose the RDMA ability. If you're not going to use RDMA anyway, fine. If you do, and you still want the resiliency, you have to basically move to L3 network. So you have to move to a case where instead of trying to team the NICs, you basically use the fact that each of these mechanisms or each of these traffic flows in Windows Server can know how to use two different NICs or multiple NICs and route traffic in parallel to all of them. SMB multi-channel will do that for the storage traffic, so it can use both NICs. The cluster traffic can do the same for the cluster heartbeat. Live migration can use multiple networks. So basically, just instead of NIC teaming, you do end up with multiple data center networks, but at L3, you balance the load between them and you use both at the same time. So you can do that, just not with NIC teaming. And SMB multi-channel has been improved both in terms of performance, as well as the ability to access like the file servers better. So it's been improved in R2, which brings us to the question of, okay, so how do I deploy that? And as I said, there are a lot of documentation on the web that explains to you how to deploy these basic units and PowerShell samples that you can automate Windows Server and deploy this thing. But one of the key things that we wanted to make sure that we do in Server 2012 R2 Wave was actually to show that you can, or to integrate with the management stack, right? So the answer to how to deploy that is actually to use System Center Virtual Machine Manager. So Virtual Machine Manager can now deploy file servers just like it can deploy compute nodes, Hyper-V hosts. And to demonstrate that, we have Hector here, who is going to walk us through a demo of how you deploy these basic units using System Center Virtual Machine Manager. I think you need to log in. We'll focus on the file server because that's the new thing in R2 for provisioning file servers and spaces, and all yours.
Great. Okay, hello and good afternoon, everyone. My name is Hector Linares. I'm a program manager with the Virtual Machine Manager team. So what I want to show you here is Virtual Machine Manager R2 deploying scale-out file servers. So I'm going to take a step back and first ask, how many customers are here today using VMM bare metal provisioning? The ability to bare metal provision a Hyper-V physical server with no operating system. Okay, so just to quickly recap the components that make up that feature, and this is in previous releases of VMM. The key components that are required to bare metal provision a server with no operating system is first you have to communicate with the server to power it on, power it off. So for that, we actually integrate with what are called baseboard management controllers, or BMC cards. Think of an HP ILO or a Dell DRAC. So we need an IP address, we need credentials. Once you access that device, you can power on the machine. And if the BIOS is set to PXE boot, what's going to happen is WDS, for example, can pick up the PXE request and start pushing down a payload. Payload could be WinPE, right? The pre-installation environment. That's the environment that's used to then prepare the server. In the Hyper-V case, the OS disk is prepared, the VHD is downloaded, the boot config is set up so that it can boot from VHD, and then with a few more steps, you have a Hyper-V server. We can take those Hyper-V servers and then cluster them. And so now you can use that for compute. So we said to ourselves, well, we already do this for physical Hyper-V servers. What if we apply the same concepts to a scale-out file server? So what I have here in the library are what are called profiles. And profiles, think of them as the building blocks for the template that you want to use to deploy physical machines. For those that are using VMM today, a VM template is made up of a OS profile, hardware profile, app profile, okay? For the physical server case, we're going to use physical computer profiles. In the previous releases, it used to be called a VM host profile. So we switched the name and now made it generic so that you can deploy multiple roles. So in this physical computer profile, I can right-click and create a new profile. So when I give it a name, I get to select what type of role this profile will be used for. So you can't have, at least today, you can't mix and match between different roles. You'll have to pick one or the other. So in this case, I'll pick the Windows file server role. I will go and browse in my library, this is the VMM library, and pick the VHD that I want to use to boot from VHD. Now I get to then specify all the NIC settings that I want for every one of the adapters on that physical machine. So if I want DHCP, static IP address. One of the key things that we use to actually identify those NICs is what's called common device naming. So we've worked with industry partners to ensure that if you name those devices, physical devices in the BIOS up front by name, you can then match them here in VMM to say, for example, this is your production network. So you can do that for every NIC. You can specify the IP information. And then finally, you can also say how you want to configure the OS disk that's going to get provisioned. And then you specify your domain credentials, local admin password, product key, essentially everything you would do to start up a server, get it built up, make sure that it's licensed and everything else. So far I've only created a profile. This is just data in the database. Now I'm going to use this profile to actually create the servers and essentially create the cluster. So I'm going to switch from the library view to the Fabric workspace. In the Fabric workspace, we have storage, compute, and networks. So if I go down from storage, I go to file servers. What I can do now is go to create. I'm going to go to the top of the ribbon, hit create, and then from create, I can create a file server cluster. So this wizard is actually going to walk me through all of the steps so that I can actually provision a file server cluster. So the first thing I have to do is actually give this the name. So cluster name and scale out file server. So these are the two IP endpoints that are going to be, or the endpoints on the network that will be used to communicate with the device. So I need a cluster name, and then once the cluster is enabled, I need a scale out file server. So that's going to require another name on the network. So I give those two names. Now I can specify, or I can pick here two paths to create a cluster. Either I can select existing machines with an operating system already configured, ready to go all on a network. The more interesting one is if I go down to the second option, and this is where I get to pick my profile. Now I'm going to actually go through a bare metal provisioning of the scale-out file server. So I already have all of the settings that I want. I don't need to re-enter those. That's why I'm using the file server profile. And now I need to tell VMM, in order to deploy these settings to some number of machines, you need to tell me what machines to actually go and look for. So the next step is to specify the baseboard manager controller protocol that I'm going to use to communicate with the device. So in this case, I just gave it a credential to say log in with this address. You can pick either IPMI or Smash. And then you give VMM the range of IPs to actually go and interrogate on a network. So again, these are the IP addresses of the BMC cards. Obviously, there's no OS on the machine, so there's no other IP address to use. So I can give, for example, a range of IPs. And then VMM is going to go off and try to search for those BMC controllers. So I'm going to cancel this workflow. And basically what would have happened at the end of that wizard is that we would have kicked off a multi-step workflow to actually go and provision these servers. So we would have powered on all the machines, let them PXE boot, WinP would download, we would start prepping the OS disk, the VHD would get downloaded from the library, the boot config would be set up, we would then reboot the machine, we'd go in, enable cluster role, enable file server role, cluster the machines. Once they're fully clustered, we would then enable the scale-out file server role within the cluster. And then once that's done, what you end up with is let me cancel this. You end up with a fully configured scale-out file server that you would see here in this view. So now it's already under management, and we're using a new unified cluster-aware spaces provider that actually gives us a full cluster view of that scale-out file server from a spaces perspective. So the second feature that we've added now in R2 is the ability to actually provision those file shares from spaces. How many of you are familiar with spaces, storage spaces? Are you using them today? Okay. So one of the first things that I have to do, again, going back to the architecture that Yigal was talking about, you have a bunch of physical disks that you need to put into a pool. So the first step is actually go and discover them. As part of the bare metal provisioning process, we'll go off and discover those disks. So if I wanted to create a pool, I click on my file server. At the top of the ribbon, I get to manage pools. So I already have one pool managed, but if I wanted to create a new one, I can go new and select some number of disks. I'll call this demo, and I'll make it gold storage. So VMM is going to go off, talk to the provider, put all the disks into a pool, refresh the information, and once that process is done, I can go now and create file shares. So what I'm not going to do is actually go to the cluster, create a space, add it to the failover cluster, initialize partition. You don't have to do every one of those steps. We'll actually take more of an intent-based management approach where you can create, so I'll go back to the ribbon, create file share. And so you pick the file server where you want to create a new share. Give it the file share name. pick the type of storage where you want to provision this file share. In this case, I want to pick from a pool. Pick the pool itself. I just created the demo pool, so I'm going to pick that. I can either give it a new classification or let it inherit whatever classification I just assigned, and then I give it a size. So the key piece here for this part is that we're actually orchestrating all the backend operations to ensure that we create the space, initialize it, format it, partition it, add it to the cluster, and then get the file share created on top of that. So the end of this workflow, now I'm flipping back into the failover cluster UI. If I click on the scale out file server and look at the shares, I've already got VM store 03, and that corresponds to the share that I just created. So obviously the last step is then I want to deploy VMs to the share. So if I go to the server view, which is on the top of the list, I'll click on Hyper-V cluster. I'll go to the properties for the Hyper-V cluster, file share storage, and then I'll click on add. In this case, what we're going to do is expose this share to the cluster. So since I'm using shares, I'm not going to unmask. We're not talking about LUNs. What VMM will do is actually ACL the share with all of the computer accounts in that Hyper-V cluster. So after that process is done, you can then start deploying VMs to that file share. Okay, thank you.
Thank you. So one point to note here is that although Hector just demonstrated that he's doing it from VMM from the UI, VMM is also fully automatable, and it has its own partial way to drive it. And if you're building a cloud and you want to automate these kind of tasks, you can still do that, but now at a much higher level of abstraction, right? So you can automate creating a file server using VMM and defining your computer profile that describes how your file servers needs to look like from a networking perspective, and then drive this as an automated way. But instead of talking directly to Windows Server PowerShell and going through the deep level of granularity of automation, you basically get it as a deploy a file server as a command that you drive VMM to do for you. So really powerful, still fully automatable, just at higher level of abstraction, and this became possible because we've aligned our efforts around Windows Server and System Center coming together with the same set of features and both supported in 2012 R2. So let's go back to the diagram we had around the footprint or the blueprint for a cloud and just complete the picture because we spent most of the time on the infrastructure level. But let's see what we have that will help you build a whole cloud environment, like a whole cloud stamp. So first thing, if we talk about a scale unit, it's really the same thing, right? So you have more compute, more storage, more units of the same type, same architecture that you want to have there. Some points to think about when you start scaling beyond this basic scale unit is your cluster size for the compute. You want to go with larger cluster probably because it's more efficient. And you want to also consider clustering across racks or across failure domains so that if one rack goes down, you can fail over to the other rack, and you can do that with Windows Server. On the storage side, your file server clusters are really not, they don't have to be big, and it actually doesn't make a lot of sense to make them big clusters. You're using file servers to drive access to shared JBODs. And shared JBODs are basically anywhere between 2 to 4 shared SAS connections. So your file server cluster will be a small size cluster, 1 to 4 nodes for the file server cluster. On the network infrastructure, so the networking between those racks, between the scale units, you really need to think whether you want to go with an L2 network or an L3 network. Yesterday in the Azure talk, there was a good discussion around how Azure does it with L3 and the oversubscription that is going on there, the multiple layers of network between the racks. So that's something you have to design for. One point to note that if you are using RDMA to get fast access, basically fast east-west traffic between your Hyper-V host and the storage, if you are using RDMA, there are multiple variants of RDMA, RoCE and IWARP. IWARP is routable and RoCE is L2, so you have to go with the right technology based on how you architected your cross-network cloud. You often also want this dedicated network for BMCs, which we didn't really talk about, but just part of the consideration. So this is how you basically, a little bit about how you scale. It's not deep, but give you a glimpse of the things you need to think about. Obviously, Windows Server 2012 scales well. There is the amount of the investment that went into Windows Server 2012 to basically get the scale question out of the picture, which means it scales to the point where we haven't seen a single customer telling us it doesn't scale enough anymore. So the improvement factor between 2008 R2 and 2012 was enormous. You can run large virtual machines, large clusters, a lot of VMs on the cluster, a lot of memory assigned to the VMs. Basically, if you have any doubts about the ability of Windows Server to scale, you shouldn't. And it's not a surprise that Server 2012 R2 basically just kept these numbers, because this is an area we didn't feel we have to invest in anymore. Really, we've changed the conversation, I believe. Going back to the full stamp, the next thing you want to design for is the access of the tenant VMs to the network, to the internet, right? And in 2012, we've introduced the site-to-site VPN as part of 2012. So you can deploy a site-to-site VPN gateway. There was a design point where this gateway had to be one per tenant. So if you're running an infrastructure IaaS cloud and you want to allow your tenant VMs to connect back to different sites for different tenants, you had to deploy a VM for each of those tenants that will act as the site-to-site gateway between the VMs of that tenant that you're running on your cloud and the tenant's site. In 2012 R2, we've made that multi-tenant, much more efficient. You can now deploy a single gateway that will be multi-tenant and will connect multiple network virtualized VMs of different tenants to multiple different sites. There are two talks that you probably want to go to if you want to learn more about that capabilities, but it's really a key piece in the story, because you really want to have those tenants being able to connect back to the network, and you want to be efficient in doing that, and the multi-tenant gateway really enables you to do that. So key investment in Windows Server to have the multi-tenant gateway built into the box. Yes? Can you speak up a little bit?
Have KMS service in order to activate the virtual machine and the tenants. How you can expose it to them again?
How you can expose the gateway to them? So the question is, how can I expose the multi-tenant gateway to my tenants?
No.
No.
You have a KMS service that you want to provide for activating the virtual machines of the tenants.
KMS, okay. So you want to have a KMS service to allow your tenants to activate their VMs, and the question is how to expose that service to your tenants.
Without exposing it to the internet where it can be seen by all other applications.
Okay. So I think, I'm not sure this answers exactly your question, but I believe it does. So if it doesn't, we'll need to follow up offline. There is another feature here which I didn't even talk about, which is automatic activation of tenant VMs by the license. So if you are a hoster and you're running on a SPLA license and you have licensed the Hyper-V servers, it actually happens behind the scenes for you in Windows Server 2012 R2. Right, it does not work for older version, you're right. Yeah. So if you want to follow up offline and you have specific question, I'll be happy to get you in touch with the right people. I'm not a licensing expert, so I can't answer that. Yes? So this is so the question is the gateway a VM running on Hyper-V? And the answer is yes. This is a VM that you can instantiate on a Hyper-V. I'll give you one guess of how you instantiate it. Of course, VMM. So with VMM, you can instantiate that gateway. You can basically set the right policies so that this gateway will connect those VMs that are network virtualized behind, like on Hyper-V, connect them to this gateway VM, and this gateway VM will basically have two network connections, one to the network virtualized network, and one to a non-network, to the physical network, or to the NICs that are not network virtualized. And once you instantiate that VM on one of your Hyper-V hosts, it becomes your gateway, and you can route multiple tenants through the same gateway VM because it's multi-tenant, of its multi-tenant support. Okay? Yeah, so the question is, how does exactly it works? There are 2 deep dive sessions that will cover that in a lot of details. The short answer I can give you is that VNM will configure it for you. And we do take care of all of these complex set of policies that are required to make sure that multiple tenants, although they go through the same VMs, are getting properly isolated from each other. But if you go to one of these 2 sessions or both, you'll get all of the details of how exactly this is done. Okay? Any other questions? Okay. So this is from a networking perspective. Going into management, so you need a management stack. Let's start with the infrastructure and then talk about the management solution. At the infrastructure level, we've invested in 2 areas. One, which is the data center abstraction layer that allows you, starting from this version, to manage, or we've taken a big bet on standardized management of the entire data center fabric, right? And that includes managing compute nodes, managing storage, and managing network devices, and managing the OS and services, right? So we've been doing WMI to manage compute nodes. We've been using SMIS and continue to improve that to manage storage. A new thing that's coming up now is our work with the industry to light up OMI support inside network devices. And what this combination will allow us to do is basically deliver on our vision of a software-defined data center. Everything can be controlled in a standardized ways from Windows Server, and think about the case where you can use PowerShell from a Windows Server management box to configure the switches, to change VLAN settings, these kind of things through OMI, and configure storage through SMIS, and configure, obviously, compute hosts, and basically get to a place where we have an abstraction layer that gives you a standardized view of all of the devices in the data center. So that's really the promise of DAL, where we are starting to deliver on that in 2012 part of our CloudOS vision, have a standardized way to manage the data center. DSC is another management technology that came into Windows Server 2012 R2. It's basically an extension or improvement to PowerShell that allows you to define desired states configuration in a prescriptive way, meaning you can describe the state, how you want the system to be configured, describe dependencies of how you want to get together. Like if you need to deploy a service, it needs to have a different service in place in advance and stuff like that. And with DSC, you basically get a good DevOps support to be able to say, I want the system to be configured that way. That's how an IS server needs to look like, or something, or that's how a Hyper-V server needs to look like. And it will scale well to manage large number of hosts using PowerShell, and it will keep the configuration correct. So it can go in and check whether the system is properly configured and basically run the right configuration to get it to not drift. So these 2 are basically improvements at the platform level, so Windows Server features. There is a session on DSC. There is no session on DAL, but there is a link there that you can follow and read more about it. But those are at the infrastructure level. At the management stack level, your management stack is really a combination of what we have built into Windows Server as infrastructure roles, combined with System Center various components, right? So all of the infrastructure role, like Active Directory, DNS, DHCP, WSAS for update, WDS for deployment services, all of these are basically roles built into Windows Server. And then VMM becomes your fabric manager for managing the compute and storage fabric. Use Ops Manager for monitoring the system. Use SMA, the new version of Orchestrator, for orchestrating tasks around your cloud. Use DPM for backup. Actually use Hyper-V Replica as well here for disaster recovery scenarios. It's not listed in the deck, but very relevant here. Use SPF and the new Windows Azure Pack as your portal and API. We'll talk about Windows Azure Pack in a second. Everything you need in order to build a cloud really exists within this combination of Windows Server and System Center stack. You can build a complete cloud using that, using those components. So there is if you haven't gone to one of the overview sessions around System Center, and you want to get this orientation, that's probably helpful. But really the point here is to show you that we have a complete stack that will allow you to build a full IaaS cloud using Microsoft technologies and go from the infrastructure level all the way up to everything you need from management. Which brings us to the last piece, which is the portal and API. How do I actually get my customers, my tenants, to connect to my cloud and consume resources? And anyone here has been to one of the sessions around the Windows Azure Pack yet? Raise your hand. One. Okay, so for those of you who haven't, I highly recommend that you go there, because what we've done in this release is we've basically taken a lot of the learning and a lot of the assets that we have in running in Windows Azure and have made them available to you as part of this a cloud OS vision to enable you to build a cloud that is behaving and looking and appearing very consistent with Windows Azure. And the reason we do that is because we believe that we want to enable developer, we want to enable your customers to be able to easily consume the cloud in 3 different ways. You can consume it from a private cloud, you can consume it from a hoster's cloud, and you can consume it from Azure. And the transition between these needs to be as easy as possible. And what we've done is basically, if we had Azure running on Windows Server already, so you can now build a cloud that is based on Windows Server and System Center running the fabric, and it's the same hypervisor, so the same. So you have good workload portability between a system between Azure and the cloud that you build on Windows Server and System Center. Then we've taken the APIs of Azure and the Service Management API and have made these available as part of the Windows Azure Pack, so that you can deploy this on-premise and get the same API surface that Azure has. Then we've taken the portal that Azure has and put that into the Windows Azure Pack. So you can deploy this on-premise and get the same portal, the same experience to your tenants, that they will be able to go into your portal and have a very similar experience to Azure for deploying their website, their application, manage their subscriptions. We went further and took that portal and made it available to you as well to manage the offerings that you're offering your customers. So you can use the Windows Azure Pack to say, hey, I want to have a gold plan. That means my customers can go in and subscribe to that gold plan, and they will get a ability to rent VMs and ability to rent websites and stuff like that. And then we went even further and took some of the high-level, the multi-tenant services that are running in Azure and have made them available on-premise as well. So you can now run high-density web hosting on your Windows Server System Center-based cloud infrastructure. You can run VMs, obviously. You can run SQL. You can run Service Bus to enable developers to consume that and run and build applications that use the Service Bus as the messaging service between their inside their applications. And future services will keep moving to this Windows Azure Pack. So we want to enable you to basically build a hosted cloud on-premise that can deliver to your customer the same benefit that they can get from Azure, and deliver them a very smooth experience, a consistent experience when they consume either a private cloud or a hosted cloud or a public cloud. They get the same look and feel and the same or consistent API experience. I don't have the pointer here. I do have the pointer for the session later in the related content slide. But if you haven't gone to one of the sessions about the Windows Azure Pack, you should. And one point that is actually nice to know about it, that this is really free. This is all, you can just use it. It's not a separate license that you need to go with. If you have the Windows Server and System Center license, this is a free download that you can go in and use and start building clouds that are consistent and compatible with Azure. Okay, to summarize, Windows Server 2012 is really the foundation, and we've improved that in 2012 R2. System Center provides you with the rest, with all of the management stack that you need to build a complete cloud. Windows Azure Pack delivers this consistent experience between private cloud, hosted cloud, and public cloud, makes it a consistent Cloud OS experience. Go build your clouds on Windows Server and System Center. It's an R2, everything here. So Windows Azure Pack is new. It's coming up with R2. We have some pointers here. I have some pointers here for additional sessions that you may want to go and listen to get either a deeper understanding of some of the Windows Server technologies or broader understanding of the relevant management technologies. You can find me later at the Ask the Experts. Feel free to email me with questions. Feel free to follow me on Twitter. This is the standard slide, and I really would like to ask you to please provide your feedback. Let me know if the session was useful, and I hope you have enjoyed it. I'll open up for questions, although we are out of time, but let's see if there are a few questions. I'll be happy to answer them. Yeah. There was a system. There is a code for the session about Windows Server, about System Center Foundation. Basically, it's an overview of System Center capabilities. So I think that's a session that's worth attending.
No, it's not a session. If you go back to slide, it's more.
Yeah.
More. No, before that.
Let's take a look at this offline. Any other questions? Okay. Thank you.